Hello, and welcome to Today in Sudoku. We're going to be covering the topic paint by numbers today, and I don't mean this kind of abstract art, which isn't really how I use color in Sudoku solving, but we are going to talk about simple coloring and steps related to simple coloring that pop up in some of the puzzles we've had recently, and that we choose some of the ones which have some of the more telegraphed locations, as long as you have a sense of how to try things in your mind and see locations and maybe even use color with pairs of digits. We talked in the last few days about a census of all the 17 given puzzles. There are 49,158 essentially distinct Sudoku. We've now posted 3 of those in the last 3 days. We've got a lot more to go, but they were ones we chose to have some fun properties. One of them was more in the 2 camp, 2.4, 2.6, I think it was. And the other 2 actually are at 4.2. So the 2 we're going to cover today. Sudoku Explainer uses the step called a W-wing. You don't need to know what the heck that is, but they're sort of in this mid-range in terms of the breadth of the distribution. They're still there are only 13% more puzzles harder than these within the 17. So these aren't as hard as we can get, but there's some pretty interesting ones. And we're going to cover the one from 3 days ago, which was the first Sudoku haiku we posted: 2 tetrominoes, 2 dominoes, 5 singles, just enough to solve. And then we're going to cover the spectacular sunrise. So let's see how these go. So this is the 2 tetrominoes puzzle, and we're going to restart our clock. Make sure we're in number mode. I'm often always in some kind of coloring mode by accident. I'm just seeing sort of different things happening here. I now see an 8 coming across. I'm just going to follow it. A lot of the start of 17 given puzzles is going to be very fast placements because of the limitations of how these grids have to solve. You don't get a lot at the start, so they have to have a lot of things going on, or they're not going to have one answer. This 4 coming down is nice. What does that do? I see actually a 3 coming down. I see a 5 coming down. I'm seeing too many things I want to follow up on. So let's just try to stay a little bit in control. This 3 gives 4. This gives 3. That 4 gives a 4. This 4 note. 6 coming across, 6 coming down gives a 6 note and a single 6 up top, which puts in a 6 here, puts in a 6 here. I haven't marked this yet, but this is 4, 6, 7 because of the 1, 5 pair. And one thing that I like to do is sort of lock in things I've noted, so I'll just mark that pair visually to the extent it matters. That then just tells me I've locked in the cell, and put in a 6 note. I've got a 9 coming up. Do I have anything more that's easy? I got a 2 coming across, which gives me another pair. I'll just mark that in. Let's do another color just for kicks. Puts in a 2, moves down a 9, gives me a 1, gives me a 6, gives me a 7, gives me a 1, gives me a 5. This is 5, 7. This is 9. I got a 2 coming across, gives a 2 coming across, gives a 2 in the cell. This now looks like a key thing to work off of. I'll use green again for this just because it also has the 2. This row now is 5, 9, 7. The 9 is locked in 2 of the columns. So here we're going to do a first form of a different color, and that's because I'm actually seeing the start of a chain, and the 6 note's no longer good. We'll clean this up soon. Whenever in some puzzles you see a few of the same pair of numbers, it's more in the hardest puzzles it will be different numbers, but maybe one candidate is in common. But in this case we have this 5, 7 chain across 4 cells is starting to come up, and there might still be some more to do here, but I, at least in looking at the top, want to look at this, and there are a few places I might want to look at this. I'm just going to do some cleanup while I'm going through this. So this is 7, 9. This is 5, 9. This is 5, 9. I need a 7 over here. Do I know any more than that right now? I think that's about what I've got. I need a 5 in one of these cells. And I have 6, 7. So this 6, 7's over here. This will be a 6, 7. Okay. So let's come to this and let's sort of remove the multicolor and go to a more focused understanding of why, like, a chain that's an even length, not an odd length, is pretty interesting. At the end of an even length chain are going to be 2 different numbers. So if this were 5, this is 7. If this were 7, this is 5. Cells like these and cells like this one see both of those colors. They see blue and yellow right now, and that means they don't contain those numbers. And so the most interesting spot is not this one, because this already has like 2 and 9 as options for it, actually 2, 7, 9. So this would just be 2, 9 after some elimination if the 7 goes away from the cell. So right now it already sees a 5, but it doesn't see a 7. It's effectively doing that. Look at this cell. This cell is a potential naked single because in Snyder notation it doesn't have a 3, doesn't have a 4. So this is 5, 7, 9 at this moment. But because it sees blue and sees yellow, it's not 5, it's not 7, it's exactly 9. And that sorry, I'll get better at this someday. Another thing to note then is after we place that 9, this cell also, like both of these cells could potentially be singles. This cell can't be a single, but this is the cell that sees both of these. So this also can't see 5, can't see 7, doesn't see 4. So right now, if you thought this was this is only a 3. And actually coming across here is that whole set. So marking all of those in is going to give us a ton of progress. It now gives us, basically the 5 has to be in the blue cell, because it's not in this cell, it's not in this cell. That's going to color in all of this. The 7 comes in, 2 comes down, 9 comes up. This is the last 2, puts in a 2. We have finish this column out. This is 9, this is 5, 5 comes down. This is 6, 7. The 6 moves down. This is a 7 here, gives 7, gives 5, gives 5, gives 4, gives 4, gives 2, gives 2, gives 8, gives 8, gives 9. This is the 5 moving up, moves the 7 to the left, moves 7, 6, 7, 6, 4, 4, 3, 3, 9. And we're through in incredible time, not awesome time, we could be faster, but this is a space where hopefully the standout pattern, again, I looked through roughly 20 or so valid haiku selected for a given difficulty range to find one that had a haiku Sudoku with a nice remote chains kind of step. Again, this could be called a W-wing with slightly different form, but these two, a single into another single, was a nice resolution of this puzzle. And again, it helps by just using some colors, doing some good pairs, doing some arcs. So this is the spectacular sunrise that we claim the AI selected from the list, and it was just trying to go off picking, just, why is this default to color? I can make notes, like that I can make notes in this mode is why it's kind of a trick whenever it happens. So I'm just going around sort of finding the number bursts. And in this case, 5 is a clean number burst to get them all on the grid. 2 looks pretty good as a number burst. Get this one, get this one, get this one, get this one. So all the 2s and 5s are in the grid. We've got some 7s coming up here. 7s coming up here. We got this 8 also as a pair. We now have 1 and 6 and 9, at least behind 3 and 4 in this space. So we'll just put in the... Put in the 3, put in the 4. This is 1, 8, 9. That 8 moves down this. This now is finished with a 6. This has these numbers, a little over notating, but it's okay at times to just be deliberate if you're going to be notating the grid. I see a 4 in these cells, that then gives this 4, gives this 4, gives this 4. Got a 4 note here. I see a 6 in these cells, gives a 6, gives a 6. 6 up top, 6 over here. I'm now looking at this row. I've got 3, 8, 9. 2 of the 3s are given, so this is 8, 9, 8, 9 coming across. That 3 all come up to give me this 3, this 6, this 6. This is now 1, 9. This is the last 9. This is 1 across these cells. Let's see here. This 7 coming up gives us a 7 in these cells, and the 7 says not a 7 here. So there's a 7 here, gives a 7 here, gives a 7 here. I'm getting 8, 9. This is also 8, 9, so I'm seeing a theme with maybe 8, 9 developing here. 1, 3, so this cancels. This is a 1. This is an 8, 9. I wonder if we can force the 4, but I'm not sure yet. Anything else I really want to mark? The 1, 3 is not going to do anything. I'd love to get a 7 note, but they're all across these. I think this is a good time to sort of go through our coloring exercise. And again, we won't exactly know if it's the 8 or the 9 we care about, but a whole amount of this grid is seen by this irregular pattern. So we want to look at this irregular pattern. And some of these, like these on the bottom, are not as critical to mark, but somewhere across these cells is a yellow. I only have this 9 in the grid, and it's compatible with anything I use. I only have these 2 8s in the grid, but this 8 is at least seeing into the space. So one thing that this could influence is particularly maybe across these cells. So let's say yellow is we're gonna do this on 8s. If yellow is an 8, then this is an 8, and now if this is an 8, notice that there's no space in this box for an 8. What that suggests is instead we need to get probably the 8 in this cell, but for sure not an 8 in this cell because of this. We could maybe see that another way by recognizing it coming from blue. Like if this is blue, for sure this is blue in the 8s. And that chain can then extend sort of further. So you can try to color more. Like once this is an 8, or this is an 8, or this is an 8, these chains go longer. And eventually we're going to find we need to have an 8. Because we need to have an 8 in these boxes, this is going to be a special cell to keep active. And as we said, 8 is not yellow, 8 is blue. So we're going to make this 9, 8, 8, 9, 9, 8, 8, 8. That gives a 1. Puts in a 9, gives a 9. I have a 9 note. The one coming down is in one of these cells. That's 1, gives 3, 3 below, move 6, 4 over, 6 to the left, 1 with 8, 1 with 7. I'm sorry for going fast. This is just sort of how puzzles conclude. I'm trying to use my notation as effectively as I can. We're going to remember to not turn this in without finishing the bottom. But there we go, another effective solve. So seeing that the 8 9s, and this was somewhat organized so the 8 9s would be the high values, but they'd be a consistent pair. When you have a chaotic, like if you have a lot of pairs like this, that's less interesting. But when you have a chaotic set that are sort of on diagonals, these 3 in blue and these 2 in yellow sort of prime different activity to happen in the grid, and that helps go through how to solve and see these puzzles. So we hope that gave you a little bit of how I at least paint by numbers, things to think through of other puzzles we've had on the site. We recognize that this is not, in everyone's mind, a logical style, but you can keep these in your head. You don't have to be doing long brute force chaining to sort of find the solutions. And the line of what's a brute force chain versus what's not is challenging to define, so we're not going to try to do that here. Before we end, we have sort of one question or one teaser that we want to bring up, and we're going to cover this over the next few days. There's still something that's a little unresolved about some of Dr. Sudoku's puzzles. You know, they've been making different selections, curations from ideas we give them, but sometimes they're also just a little off the rails. And the first puzzle, for instance, they put out there was larger than we expected, not exactly a grid we expected. We've not seen anyone in the outside community sort of fully describe what's going on with this. But we have seen our old rival, Mr. Evil. We mostly ignore this person. They're a little irrelevant in this day and age, but you know, maybe 15 years ago there was a story where Mr. Evil was taking over a puzzle hunt we were running. And so Mr. Evil has tweeted recently, well, whatever the new thing is, he's X'd recently. While the rest of you are enjoying Dr. Sudoku, did anyone notice how many grids were borrowed from better authors making complete puzzle books of championship puzzles? And Mr. Evil is big on computer generation. His full name is Kenneth Kenevil, but he loves the Ken and other things that sort of, you know, the Kenneration is his excitement. And so he's looked at these grids, and that upper left one, that extra space Sudoku, looks visually a lot like Dr. Sudoku's first puzzle. That doesn't seem good if they're copying visual elements. So what's going on here? Hashtag so sad. I'm not sure I agree. Like Dr. Sudoku did not copy from those books, but something else has happened. And we need to get to the bottom of it. So if you want to help us set the record straight, we're going to tell more of the story starting tomorrow of things to recognize in these grids. If not that, you can always like, you can comment, you can subscribe, you can solve, you can construct. Today we're having antibody is the theme for the puzzle, and we'll have other science Sudoku in the coming days. I am a trained scientist, even if these days I'm mostly a puzzle maker, but we love making puzzles that tell stories and just a visual story for a less common object, in this case an antibody. This was a puzzle I made in 2014 while at an immune medicine company. I'll tell a little of that story tomorrow, perhaps. We'd love to have other ideas, not just from Dr. Sudoku of Science Sudoku, And feel free to join our Discord. We've had some recent discussions on biology and how AI will or will not help in medicine and other problems of understanding the cell. So that we're not just puzzle makers and puzzle solvers on the Discord. We've got a fun community, and we'd be happy to have you join. So thanks, and we'll see you soon.